When we're looking at triangles, especially similar triangles, congruent is almost exactly that, a similar triangle. But the thing with congruent triangles is what happens is all corresponding sides and all corresponding angles are equal. So if we look at this first example, we can kind of see that this goes 1, 2, 2.5. So if we're going 1, 2, and then 2.5, what we're looking for in the second triangle is the same thing. We've got 1, 2, and 2.5. As long as they're in the same order, if I can kind of go around the triangle the same way, 1, 2, 2.5, 1, 2, 2.5, I know that those are all the same. And now the second thing would say that if all the sides are the same, then this angle is the same as this angle. This angle here is the same as this angle here. This one here is the same as this one here. Now if we look at the next example, we can see clearly that these are the same triangles. So that would mean that this x is equal to this x. Okay, now on the bottom, they give you something a little bit more difficult, but knowing that all triangles add to 180 degrees, that would tell me that this is 49 and that would be this is 41. So then I know that these are all congruent. Okay, it's just three different ways to look, but all three of these triangles sets of triangles are the same. Congruent means the same sides and the same angles. When we're looking at similar triangles, they're almost like congruent, but they've been changed by some ratio. All the angles are going to stay the same. So all corresponding angles are equal. But the sides have been multiplied by a common ratio. Okay, and that gives us some other things. There's some other properties that go along with similar triangles, not just the sides, for instance. So if I look at this, I know that this and this are corresponding sides. So I can find the ratio by doing triangle 2 divided by triangle 1. Those are triangles, not D's. I'll switch that, make it a little clearer. Okay, so triangle 2 divided by triangle 1. So I know that I can have 8 divided by 4, which is 2. So the ratio here, I could find this side by doing 3 times 2, which is 6. I could find this side by doing 5 times 2, which is 10. The ratio has just increased everything by 2. Some properties about similar triangles. So if K, L, and M are similar to TUV, that means that all the corresponding angles are equal. So we know that all of our angles are equal. So L and U are equal. K and T are equal. M and V are equal. The ratios of the corresponding sides, that's what we were just talking about. Everything's been increased by a ratio. Okay, side M would be equal to V times some ratio, or divided by some ratio. Okay, so when we're looking at this, this would be M times the ratio. This would be side K, so then this would be K times that ratio. Okay, this would be L. Okay, all lowercase letters are side lengths directly across from the angle. Okay, when we're looking at triangles, that's something we should address. So this would be L times that ratio. But if we're looking at triangles, so for triangles, okay, our capital letters or uppercase letters, what I like to write in, are always your angles, A, B, C. So uppercase is angles. Okay, lowercase, and lowercase are always directly across. Whoops. Are sides. Okay, so A, B, C. So when we're looking at this, that's kind of how we've got this. And then the ratio of the areas is equal to the ratio of the square of the corresponding side. So the ratio of the area So when we're looking at the ratio of the area, we're talking about triangle. So in this case, it would be triangle TUV over triangle KLM is equal to the ratio of the squares of the corresponding side. So area of TUV over area of KLM is equal to the side, we'll call it like side T squared over side, what side T correspond to? K squared. Okay, and those are some fancy properties, but we'll look at them a little bit more in depth as we're working through this. Okay, mainly when we're dealing with this, we're dealing with angles and side lengths, and those are the things that we're going to solve for. Now in this, what we have to identify is kind of where our angles are. This one's nice and clear. It's got the diagrams written almost exactly as they need to be. We need to find a ratio that we can look at between the two triangles. So if I want to set this up, I'm trying to find out what C is and also what E is. Well, I know that if I'm looking at this, here's my sides that are kind of even to each other. I'll just throw a dot there. So what that's going to show me is that D, which is here, the 5, and G are in line with one another. They're directly across. So the ratio of D over G would equal all of the other ratios. So if I'm trying to find out C, all I'm going to do is put C over F. Okay, so if we were to sub those in rather than writing the letters, I wrote these a little bit big, so maybe I'll try to shrink those down. You probably can't do that as easy, but what this is going to be is 5 over 4 equals C over 6. So then all we're going to get is 30 over 4 equals C. So then C equals 7.5. We would do the same thing with E. We're going to use D and G again because they're the ones we know. So we get 5 over 4 equals. For this one, we're looking for, what angle do we want to find? We want to find E, which is here, which shouldn't be uppercase. It should be lowercase. So let's fix that. I just went through that with you. So E. So I know E goes on the bottom because 4 went on the bottom. Okay, and that means E is corresponding with 10. So we're going to get 5E equals 40. We're just cross multiplying there. And then E is equal to 8. Okay, and these are centimeters because that's what the unit in the triangle is. Okay, when we're looking at a triangle like this, for this one we know that these have parallel lines. So we can use our Z and our F and all those patterns to figure out which angles are the same. I always like to redraw my triangles out. So I'm going to have my bottom triangle drawn right here. And now all I need to do is figure out what are the corresponding angles. Well, I know D and B are equal to each other. So I'm going to put B right there. I know C is equal to C. It's right here. So I'm going to have C right there. And then I know that I'll change these. I'll make those X's. I'll make those little dashes. So I know A is going to go here. Well, now I need to go across from A was 4, across from C was 7, across from B was 5. And I can kind of do this now with this triangle. Okay, I don't have to, but now I've got that triangle on the bottom. I'm trying to find X and Y, which X is D. So I need to find my sides that I have, both of them, which are these. And now I could just go 6 over 4 equals X over 5. Well, that's actually the exact same triangle that we just had. We get 30 equals 4X, and then X is going to be 7.5. Now we have to find Y. Okay, well, we're going to do the same thing for Y. We're going to have 6 over 4, because that's the ratio we know. And then it's going to be Y over 7. This one's a little bit different. We're going to get 4Y equals 42. Okay, and then Y equals 10.5. Okay, all you have to do is find out which angles correspond with each other and then which sides. Then we can set up our ratio. Okay, we're setting up a ratio just like we did in the past. You're making a fraction, cross multiplying to solve for the unknown.